The story begins like this. A young man named Jake discovers a portal that leads him back in 1958. After a few visits and some experiments, Jake comes up to an idea that altering history is possible. However long he stays in the past, only 2 minutes goes by in the present. He decided to live in the past until 1963, so he can prevent the assassination of President John F. Kennedy. Jake manages to save Kennedy. Upon returning to the present, he expected to find the world to improve. As a result, instead the opposite happened. Earthquake occurred everywhere. His home has turned into ruins, and a nuclear war has destroyed the world. Jake returns to 1958 once again and reset the history. Weather prediction is an extremely difficult task. Meteorologists can predict weather for a short period of time, a couple of days at most. Beyond that point, predictions become generally poor. Even our most sophisticated computers fall apart and they give up wrong data. That is that wrong that even a 5-year average of that data will be more accurate than the computers that we use today gives us. Edward Lorenz was a mathematician and meteorologist at Massachusetts Institute of Technology who loved to study weather. With the advent of computer, Lorenz saw the chance to combine mathematics and meteorology. He set out to construct a mathematical model of weather, namely a set of differential equations that represent velocity, wind, and pressure and temperature, etc. In the end, Lorenz stripped the weather down into a crude model that contained 12 differential equations. On the particular day in winter of 1961, Lorenz wants to re-examine the sequence of data coming from his model. Instead of restarting the entire run, he decided to save time and restarted the run from somewhere in the middle. Using data printouts, he entered the condition at some point near the middle of the previous run and restarted the model calculation. What he found was very unusual and unexpected. The data from the second run should have exactly matched the data from the first run. While they matched at the first, the run eventually begins to diverge dramatically. The second run started to lose resemblance within a couple of months time gap. At first, Lorenz thought that the vacuum tubes has gone bad in his computer. Back then, there was no transistors, an extremely slow and crude machine by today's standard. After discovering that there was no malfunctioning, Lorenz finally found the source of the problem. To save space, his printout only showed 3 digits, while the data from his computer memory contains 6 digits. Lorenz has entered a round of data from the printout, assuming that the difference was inconsequential. For example, even today, temperature not routinely measured within 1 part in 1,000. This led Lorenz to realize that long-term weather forecasting was doomed. His simple model exhibits the phenomena known as sensitive dependence on initial condition. This is sometimes referred to the butterfly effect. Butterfly flapping its wings in South America can affect the weather in Central Park. This question then arises: why does the set of completely deterministic equations exhibit this behavior? After all, scientists are often taught that small initial permutations can lead to changes in behavior. Let's take an analogy for a second. I finally got the way to get into the past. Even my interaction to the air molecules into my past could have a catastrophic effect. The noise that I'm going to make by walking can even make a thunderstorm. These scenarios comes into the butterfly effect. A single thing, like a grain of sand, can change the entire history of the universe. If the past is disturbed from the present, the answer lies in the nature of the equation. They were non-linear equations. While they are difficult to solve, non-linear systems are central to chaos theory and often fantastically complex and chaotic behavior. And as always, thanks for watching.